turbines which are being turned, and then when they are turned, they give energy. Okay, so this is kinetic energy. When you turn something, that kinetic energy will change into another form of energy, maybe electric energy. So you can change energy from one form to kinetic energy. You can change one energy from one form to another. Okay, so that is it. So this is kinetic energy in the form of also we call mechanical energy. Okay, being converted to electrical energy. And then the electrical energy to light. So this light, this will go and light a bulb up. So getting light. Okay, so this is just a concept of trying to bring in light as an electromagnetic wave. Okay, so light is what we call it's an electromagnetic wave. Okay, so this is just a way of getting the concept at this point. Okay, and that is what is moving. It's moving in what a straight line. A straight line. Okay, so if you have a pinhole here, it will move through it and then give you something like here with the shadow. Right? So these kind of play can all come in at this point. Right. So you can also let them see how sound travels using this. Explain another person is here. This strange. Okay, so one person shouts into this and then it travels. So this as for sound wave is like that. And then the other person with the ear. Here it's okay, so sound can travel. Okay, that sound can travel along this one. Okay, along the string. Okay, so that is that. Then you can look at that concept. Okay, so for sound wave, it's not going like this. It's not going transverse way. Okay, it's giving us a longitudinal wave, so it goes like that. So it goes like that. That is sound wave, okay? So that is longitudinal. So it's longitudinal, okay? Light and another waves, they are transverse waves, so they will move. So as this is going like that, the vibration is up and down this way, and then it's traveling this way, but the vibration is down. So this is a transverse. Transverse wave. You see, it's transverse wave. This is longitudinal wave. Okay, just this concept at this point, okay? So you can do so, and you can use the megaphone and use the microphone, okay? And sound can be made, okay? So you can look at interference. One sound is made, another sound is made, okay? And you see where you can hear the sound well, not hear it well, okay? All due to what you call interference, okay? So some interference may go up, maybe constructive, okay? Some will die, so destructive. Where you not hear any sound, destructive, okay? So constructive and then destructive. So this is under interference, okay? Interference of waves. Okay, so when you say wave is not the matter itself. So you look at it as a form of energy. What is making something move up and down or to and fro? It's called wave. Okay, so sound moves. Sound is kind of wave. Light is also kind of wave. Okay, so with that concept, so we have the play tools for this one. You can use this one to demonstrate the rectilinear propagation of light. Sorry, using the light source. Okay, I talk about rectilinear propagation of light. Is where you have a pinhole there. If you block it, you won't get any light source on this. If you have a pinhole here, you get source here. So you can use that one. That is, so they play around this one. And as they grow up, you start talking about the points. Okay, in a very advanced form, we are also going to say light probably may not only be traveling. It's not always that you look at light traveling in that straight line. Okay, so that concept will come later. Then we can convert one energy to another energy source there. Now we cannot destroy matter. That is what we are saying about. At a point we will also talk about where a small matter can be converted to energy, a huge energy. So that will come in when we advance in the case of Einstein's equation. Right, which is the E is equal to mc squared. Okay, right. So this is the concept for sound and energy at this level. Right. Now let's look at the lenses and the light. Still under light energy. Light is a form of energy. Okay. So you can have your prism. Prism is a text. You have it there. Then you have the light source. Okay. Then you bring the screen here. See, it is bent. Okay, so at this level, we are looking at what? The bending. The bending, we are looking at what's called refraction. Refraction, okay? So that is it. Now, if you have your mirror, your light source goes against it, it is reflected like that. So this is your mirror. So that is what we're going to have, okay? So the image here, let's say this is me. The image is going to be forward. Okay. So let me look at it that way. So this is our mirror. Let me put it this way. So this is our mirror. So this that we see here, there's another angle, reflection. Okay, so this light has been reflected, okay. This one is the incident. Incident is what is falling. Incident. Ray is a ray. Okay. This is not anything. It's an imaginary something like the normal. It's the normal. Okay. And this is 90 degrees. This is 90 degrees. Okay. So this is play 2. You may not need to talk about all this. Just get a set. Let them play this. Okay. Put me here and try to find the image. Okay. So they can have it here. Then behind that, they can try to see where the image will fall. Right. So at that point, they form an image and you know what you are talking about. So, so I think that is that. That when we come to the various topics. So this, we have the play tools there. You can request for them. You have them play with it, and then it's returned to us. Okay. Right. We can also demonstrate the polarization of light. Maybe we have a film, then we have another film like that. So we can rotate them until maybe no light is coming out, okay? That means we have cut off part of light. And that is called polarization, okay? And so this, we have said this is what? Refraction. This reflection. And this polarization. So maybe this another material. They are films, okay? We want light to pass through them. At the point light will be passing, at another point no light will be passing through. Then we say we have cut off some of these things. So let's say this is 4. We have only 2 coming out. We have polarized this light, okay? So see polarization. So this is just ways of trying to introduce them to what we discuss when we get to the upper class. To demonstrate diffraction of waves, diffraction of waves. This is just for demonstration. It's not. It may not be the natural phenomenon. Okay. So let's say you have a pool of water. Okay. You drop something in it, and the waves are going. You can have 2 blocks in there with a small hole in it, like that. Okay, so the waves come here, and then beyond it, they spread out like that. Okay, so this is the waves coming, and here they are spreading waves. Okay, so this is demonstrating diffractions. Kind of. I'll put it there. Kind of. Okay, so it's not the actual way to demonstrate diffraction. Okay, so kind of, just to give the picture, something like that. So that is that. So that's the play for the diffraction aspect of waves. Okay, so that is how we look at it. Right. Now let's look at sound in other playing with sound. Okay. So sound. Okay. I have the string like that. You can clap in the middle. Then you have waves. You have waves like this. Goes naturally and it's reflected back. Okay. You can have it this way and it's reflected back like that. Okay. So this is a string. You can use our guitar for it. You can use the pipes too. You fill it with water. Okay. Very small one. Okay. Then we blow air. Blow air into it. So it forms this one. This may be the first wave. Get the same thing. Then this one. Like that. Okay, so it tells you, then you can have the open pipe too. You have the first one. So because it's open, here is always open. Yes. So this is the node. This part is the anti-node. Okay. So this is just preparing them for the future. Okay. So this water column, this closed pipe. The open pipe, okay? So this is just demonstrating today some of the waves. So that's the wave, okay? So is that a typical wave like that? So this is one wave, okay? Okay. So this when it is very high, so we are seeing the amplitude. Okay, this whole thing is what we call the wavelength, okay? The wavelength. So there's the amplitude. Okay, the number of times it is going, so it will be going some number of times, okay? Number of times over time. So number over time, okay? Number of cycles, okay? Over time, and we call that frequency. We call it frequency. Okay, so this, not to mention, just the play. So we have the play tools like this also for, okay? Or that you can come for it and then return it. Right? So that's important. So just the play, the sketching. So they play around and then you make them sketch too. So as they keep on doing this, the interest will be built up. We have a program for, we also have the timetable, how you can order their study, as putting in also outing and entertainment, so that it's not always studies. So that's it. Now let's come to heat. Okay. Okay, so we have water here. Heating it. Okay, so as we heat it, it gets to 100 degrees, it changes to vapor. Okay, so this is vapor. Okay, so that process we are calling it evaporation. So heat is causing that. Right. Now, if you are heating this, let's say we have another container here, which is catching it with water. Okay, some of the heat, this is hot. It will make this one warm. Okay, so heat is being transferred by what we call conduction. Okay, right. Now the air column here, this one is air. Let's say air here. Okay, it was cold, but the air here in contact. Let's say air it comes in contact with the water. It will be getting warmer a little. It will be getting warmer a little. Or let's say, first of all, this part of the water body gets warm. This is cold. Later on, this part becomes warm. This one. So within that same material, in water, okay, water and then fluid and then gas, okay, that exchange we call convection. Okay. Now sometimes we have exchange of heat. Okay, maybe where there's no air at all. There's no air. So we call that, where there's no air, we call that vacuum. Okay, This is hot. You can transfer part of its heat to this to become warm, although it was cold, to become warm. This transfer is what we call radiation. Okay. Now the sun and so on, they radiate. They give us energy by this kind of heat. Okay, because the light from the sun goes through space where there may be no air vacuum. So the heat from the sun gets light by radiation. Radiation, like we said, is usually the type of radiation is usually infrared. Infrared, call that infrared radiation. It causes heating. Okay, when you have light, the white light that we have, is made up of so many lights. Okay, we have the rainbow part. It's made up of 7 colors. Okay, and then we have at the ends, we have the ends. Okay, so the red side, we have the red side, the red end, and then we have the blue end of the white light. Okay, all lights together, the 7 together form what we call the white. Okay, we have the red side and we have the blue side. Okay, so if you are below the red, we say you are infrared. If you are above the blue, we say you are ultra. We come to violet part. Okay, ultraviolet. Okay, so blue and violet are close electrometers, so you can look at it that way. So here, those energy on the red side, their energy is not as high as those from the blue side. The blue side, the energy is high because the frequency is high and energy is high. But here, frequency is low and energy is low. If your frequency is low, it means the wavelength is long. Here, the wavelength is short. Okay, so this is just a brief thing. So the heat that you can look at, always heat. Look at it in radiation in the form of heat. You can always look at it as infrared. Right. Okay. So that is why if you are in the prison, and then you get your rainbow colors, when you shine light through it, you get the rainbow colors. If you bring something at the extreme and maybe close to the red part, you can get that. You can feel some heat there. That is infrared. Okay. Infra means below. Infra means below red. Okay. So these are kind of things you can be looking at. So we can look at ice. This is ice. This is water. This is vapor. Okay. So this is at 0 degrees and below. So this is between 0 to 100. Okay. And this is greater than 100 degrees. Okay. Or let me just put it this way. Theoretically, you can't say that. So let me just, because it will not continue. We'll just put it like that. When it's more than 100, then you are getting it in paper form. Right. So here, this is what we have. Now, heat. If you apply heat, you melt ice to water. If you apply heat, you change it to vapor. Okay. So here it's like melting. Call that melting. We are melting. Okay. And then here we call that evaporation. Okay. Right. So when you come back, we call that what condensation. If you are converting the vapor to this, that's condensation. Okay. And then if you come back to ice, you say freezing. Okay. Sometimes from vapor straight away you can get to solid. So this is solid. This ice is solid. We call that deposition. Okay. And then sometimes from solid straight away we can go to vapor. That's sublimation. Okay. So you can look at it. This is a very good thing. At the point you can have some ice, you can have some water, and then you can have some vapor in a medium. And this we call, at that point, we call that the triple point. Sometimes when you change the atmosphere, you change the atmosphere, the pressure in the atmosphere. Okay, you change the boiling point at the point that something boils. Okay, the melting point and all those things will change. evaporation time when they will be evaporated or they will change. So at the point you have certain pressures, temperature, at which you get all these three, the ice, vapor, and water form of the liquid form of water existing together, and then we call that point trickle point. Okay. Now, if usually from here to here, the temperature will not change, but heat will be supplied. So when you are supplying heat, but no change in temperature, no change in temperature, we call that latent heat. Okay. Okay. So here, because here from water to vapor at 100 degrees, you keep on adding heat until it changes to vapor. That heat, which is not changing temperature, changing it from 100 to anything, is called latent heat of evaporation. So that is it. It can also be the same. It's the same as your condensation, but here we call that fusion, latent heat of fusion. Okay, latent heat of fusion. Okay, so you can play around with these three states of water, which will also stand for liquid. So virtually anything else can be made to exist in this form. So we have the solid. If you look at solid, and if you have the eyes to look at it microscopically, you see that the particles are packed together like that. Very, very small. They are packed together. Then liquid, they are spaced a little. Okay. Then gas, they are spaced. One here, one there, one there. Okay, so this will be solid, this will be liquid, this will be gas. Okay? Now, if you have this particle and you keep on dividing, you come to the smallest one we call atom. Now we can even divide atom into smallest one. We can have electrons, we can have protons, we can have neutrons. Okay? Something like this. Then we have the inner part, then we have electrons going around there. So this is the atom. This is electron. This is the inner part we call the nucleus. Okay. The nucleus is made up of protons and neutrons. Okay. So you can keep on breaking, and even now we can still break down electrons and protons too. We'll come to that one. Okay. So you can break down electrons and protons too. So that is that for now. Now, what I want to say is black bodies. If you have something like this, black body, black body. Any black body absorbs heat, absorbs heat a lot. Okay, black bodies absorb heat a lot. Okay, any good absorber of heat is also a good radiator. It means also it's able to, if you are able to absorb a lot of heat, you're able to give it away. So in terms of radiation, okay, those who can absorb well can also give away well. Okay, let's note, and that is usually black bodies are very good at that. White bodies will reflect all the light. White bodies will reflect all the light. Because they reflect all the light, all the 7 colors are coming together, so they will appear as white. Anytime the 7 colors are coming together, they appear as white. Right. Now the last bit I want to add is semiconductors. Okay, when you hear the word semi, it means half. Okay, conductor. We talk about heat conduction. Say solid. Okay. In solid, something that you can hold, okay? Bring another solid, heat transfers, then that is called conduction. Okay, electrons can also flow between two metals, okay? So electrons flowing is conduction, but some metals, the way they allow electrons to flow through them, so these are, then you have electrons here. This is the positive nucleus, okay? The electrons are cold, okay? Some electrons allow the electrons to flow through very fast or well. So they are good conductors, okay? But some will not allow them to flow through at all. So they are bad conductors, they will not be allow, okay? In terms of heat, to the same process. But there are some which are in between this and then that, okay? But with respect to electricity or electrons, we call them semiconductors, okay? Okay, so we have a lot of elements which will fall under this, okay? We have germanium, so on and so forth. We have the other metals, we talk about silicon, germanium, they are the two that we're looking at in semiconductors. Silicon, germanium, okay? And so these ones, we can add certain elements to them to allow them, or they are in between, so we can add certain elements to them to allow their electrons to flow. Okay? Sometimes electrons alone can move. Can move. Electrons moving, electron is very small, so moving, it can behave like a particle, it can also behave like wave. So we say it is dual. Dual means two. It is between the two electrons. Okay. So the dual properties of electrons, we'll talk about that. So this is a good thing. So the semiconductors in terms of electricity or electric current. Okay. Current. Okay. Right. So look at the periodic table, and then you see the elements which are semiconductors. They are between metals and then non-metals. Okay. The non-metals will not conduct electricity easily, like we say. And then the metals will conduct electricity well. So those in between are the semi-metals, the semiconductors, okay? Then as for the same metals to some can have their electrons existing, they can move so freely between levels. They are what we call the transition metals. We'll talk about them later. So that's this one. So the play is you have a solid, another solid. You can talk about heat. When you talk about electricity or current, then you're talking about semiconductors. You can look at it. So this one, the sketching is what is going to help. So let's say you have this metal, you want it to have this, you want it to do well, then you add another one to it. Add another one to it. When you add another one, call that, let's say this is silicon, and add phosphorus to it. You say I'm doping, okay? Call that doping, okay? When you do that, change them to what you call the diode. Okay? Change them to what you call diode. Then the diode can be changed to what we call transistors. Okay? And transistors, we can have a lot of them coming together, we call amplifiers. Okay? So we'll talk about it. So we have the play tools for these ones to just to introduce them to the topic under semiconductors, okay? And then logic gates and so on, and then transistors. Right. So I think this should be okay for us. Now let's look at nuclear physics, the last bit. So here, you must first know that if you have this solid, it's made up of small particles, okay? Small particles. If you take one, there is it. You can still cut it into two. And to keep on cutting them, a very small one. That's a very small one we can call atom. Okay, this one, let me enlarge it. If you enlarge it, you have it like this. Then you have this. So the center will have some particles in there, and then here you have another particle, usually 2 in the first part. You can have 8 in the next one. Okay, 8. So this one, so this is the atom that I've made bigger. Okay, the inner part we call the nucleus. Okay. Now it is made up of the nucleus. Inside it we have what we call neutrons. And then we have another one we call protons. Okay? So this is the electron. Those moving around the nucleus, they are called electrons. These electrons, they can jump. They can jump to the next, but they always move in the path around the nucleus. Okay? So this is the path. Electrons can jump. When they jump, when they get energy, they can jump. And then sometimes they can lose energy and fall. Okay? Right. So when they jump, they say they are excited. When they are excited, they jump. When they fall, then they give away the energy. So they radiate energy. Okay? Radiating. And sometimes this nucleus can break down. Breaking down of the nucleus. Okay? We call that radioactivity. Okay, so they can break down. So we call that radioactivity. They can break down to form other products. Sometimes instead of breaking down another nucleus, there is one nucleus, another nucleus. They can fuse. They can come together. So that is fusion. Here, breaking down, we call that splitting or fission. Let me write it well. So when they are breaking, that is fission. When they are coming together, that is fusion. Okay? So these two will fall under. When they are doing that, we call that radioactivity. They are radiating. when they are doing that, energy, huge energy is released. Okay, so if you talk about the bombs, the history, if you listen to our history, the history column, there was a time in the world history where we had what we call the Second World War. Some bombs were dropped in Japan. Okay, they caused a lot of explosions. Okay, they are huge atoms. Okay, they were made from what we call the atoms. Okay, so they are called atomic bombs. They can cause a lot of damage either by coming together or breaking apart. At this point, let's read this. So this is the atom that we have described: the nucleus with protons and neutrons, electrons moving around that. Now we'll later talk about it, but not now. These electrons can also be broken down into smaller ones. Protons can be broken down into smaller ones. We'll come to that one. Okay? And then they are arranging their powers in a different, some are giving other additional powers. Okay? We'll come to that one when you go back. Right. So thank you very much. This is a good part. So sometimes for the radioactivity, maybe you have a plate, a film here, like the picture film, and then you have a radioactive material that can break down to form other elements. Okay, it can break down, and then part of it can come and fall on the film, and then give you a picture. Maybe give you cause change or picture on the film. So this is it is radiating. Okay, it can radiate so many particles. It can be particles that will be coming. It can be particles. Okay, particles can come, or sometimes it can be just energy. Okay, or waves. Okay. So we have what called gamma waves. Okay, gamma energy, gamma waves will come. Okay, sometimes it can be particles. Can be particles. Other particles can be radiated. Okay, you can call one the alpha particle, the beta particles. Okay, can also come. Right. Sometimes it's just radiation, energy. And sometimes when the electron is moving, and then moving at a very fast speed, and then it starts slowing down. When it starts slowing down, it gives energy we call X-ray. Okay? Yeah, all that we'll talk about it later. Right. So at this point, I think this is good for our basic level. The sketch, so we first talk about playing with, so we have the play tools. This one comes usually in the form of cartoon and other things. So we have the play tools. Then you come to sketching, let them try and sketch some of these things that we are doing here. Okay, as they keep on sketching, it stays. And then when they get to that level, it becomes very easy. So you see that in this way we have covered all the topics. This is for the lower part. Of course, the play can also go for the preschool people. That is good for us all. Thank you.